Hello and welcome to Maths with Mr Amison. In this video I'm going to talk to you about how to find missing lengths in 3 dimensions using Pythagoras theorem. If you need a refresher on how to do this, then please watch this video here or follow the link in the description below. I'm going to talk through basically how to find each of these things for this video. So first of all, the length AC. Feel free to pause at any time to make sure you understand what's going on. So to find the length AC, I'm going to need to use Pythagoras theorem. And I tend to use c squared equals a squared plus b squared because it just makes things generally a little bit easier to understand when you get to more advanced trigonometry, which ties to this. So to find the length AC, first of all, I'm going to need to use a right angled triangle. Now I have the length AB and I have the length BC, so it makes sense to use the triangle ABC, with the right angle being in the corner at the vertex of B. So what we have is AC squared is equal to 3 squared plus 7.2 squared, so AC squared is 60.84, and when we square root that we get AC is 7.8 centimetres. Now for the length BH, we can use a couple of different triangles. We could use BCH or we could use BGH. Either one of them has BH as the hypotenuse. So if we use the length BH with the point C, then we have BH squared is equal to 7.2 squared plus this length squared here. Now this length is the same as the length BG, therefore it's 7.2 squared plus 6.5 squared is equal to BH squared. So BH squared ends up being 94.09, which when you square root that you get 9.7 centimetres. The length AH is the space diagonal of this cuboid. Now for the length AH we could do this a number of ways, but we have found a couple of lengths that will help us for that. We found the length AC, which is really useful, so let's use that. Let's do the triangle ACH. Now AC we've found out is 7.8. CH we've just talked about being 6.5. So if we do AC squared or 7.8 squared and 6.5 squared, well that should equal AH squared. So AH squared is equal to 7.8 squared plus 6.5 squared, which is 103.09. Therefore AH is 10.15. Bearing in mind that the right angle for this triangle is up here, okay, because this side is perpendicular to this edge, okay? And whenever you have a line that goes across a face, one side going across a face of a cuboid and one side going along the edge of a cuboid, the right angle is between the two. So we have AH is 10.15 centimetres to 3 significant figures. Now the area of the triangle FCH, this really is a little bit more tricky. We need to draw the triangle FCH in first. When we do, we can then say that, well, we know this length is 7.8, we know this length is 6.5, and then the area of the triangle is half base times height, so if we times them together, divide by 2, we get our area. The area of triangle ABH is a bit trickier, but it's worth realising that the base of this triangle is 3, the height of this triangle would be the length BH, which we've already calculated. So we could do 9.7 times 3, which is 29.1. Divide that by 2, and we get the area to be 14.55 centimetres squared. Thanks for watching. I hope you found it useful to watch how to find missing lengths and areas in 3D shapes using Pythagoras theory. Until next time, bye for now.